done these, and we said that actually a bar chart is for what data again? Discrete, but also
Qualitative.
Qualitative. And histograms, continuous, but we've got. Okay, and the difference visually between a bar chart and histogram, Karen? So a histogram has bars that touch. A bar chart has gaps.
And it runs always the same width.
Bar charts always have bars at the same width. By the way, we're not doing those questions I've given you just yet.
I was going to ask if
Not directly yet. We haven't done what's ready to do those sheets. That's why I said to Kieran not to do it yesterday. So, one thing that bar charts and histograms have in common. Yeah, they do. But what goes up the vertical axis? Frequency. Okay. Well, bar charts always have frequency. Histograms, however, could have frequency, but could also show relative frequency or frequency density. And that's what we need to work on today. Because the thing that Thibaut just said is, a bar chart, because of the fact that the bars don't represent a quantitative measure, the bars are always the same width. Yeah. So we looked. I think we got this. We looked at the book yesterday, and we looked at the charts being those ones. So we've got blue, red, green, orange. They can go in any order. There's no reason for any particular widths. Okay. What did we say about this one, Nick? The pupil to teacher ratio, bar chart, histogram, or neither? Because it's not frequency on the side. Greg, what do you do? It's not maths. It's to do with your basketball, college basketball.
Probability.
Do it in your own time. Or I'll turn up to my maths lessons with you and just start doing my triathlon training and just say it's good for my mind, and you guys can just do what you like for maths and fail your exam. That's your mentality. Okay. So the pupil to teacher ratio is it's not frequency related, the vertical axis. Okay. This one, midterm examination scores, lengths of leads. Okay. Kieran? Histograms. What type of data do we have? Quantitative, because they're amounts. Okay. What's the difference though between score and length? We were discussing this yesterday.
Score is proof and length is continuous.
Yeah, so we've got score. So this is where I think on my notes I got something wrong, didn't I? Because if we look at that, we can't really say a bar chart. Sorry, a histogram is not discrete data. Because it could be discrete, but it has to be quantitative, right? So what was the difference then? We were talking yesterday about if this is discrete data, where do the gaps go? Why are there no gaps? Yeah?
You go halfway to the next set of data to fill the gap.
Yeah. All right, so you kind of go, even if the score, it has to be a whole number, we go 23.5 is the middle of 23 and 24, that's where it goes. So with quantitative, we don't have the whole. And actually, we were talking quite a lot yesterday about the one where the ages are rounded. So the difference between that one and the other one we're talking about, Greg, you were talking us through how you would have how you would arrange for the bars to touch each other with this one. So we've got groups of 18 to 25 and then 26 to 33. Would you put the bar in the middle of 25 and 26?
No.
What did you decide was the better way to do it and why?
I would put it all the way to 26. That would be where the line starts. Because if you think about like how you talk about your age, you know, even if you are, it's a day before your 26th birthday, you're 25 still.
Yeah.
You know, you don't round up your age. Like by that logic, I'll be 15, and everyone's age would be different and stuff like that.
Yes.
It's not like the length of a tree, like the example above, where you would round to the nearest number, for example.
Yeah. So was it this one? Yeah. So this one you can see that this was heights of chicks, and we've got 19.5 to 20, 22.5, because you can round up and down on that one. But age, it's just that we don't do that with age, isn't it? So we are 18 to 25, but actually we're still 25 all the way up to 26. But the moment we turn 26, we're still 25. So it looks discrete, but there's an obvious way of filling those gaps. Right, so we're moving on a little bit because we want to talk through now about histograms, but histograms where the group sizes are different. All right, and we will at some stage talk about why you would want that. So at the moment, all we've done is where what's this called, by the way? This is called a
Class
interval. A class interval. So everything we've done in terms of bar charts and histograms, the class intervals have been exactly the same size. But do you notice that in this first question, they're not?
Yeah.
All right? So if I were to just draw a normal frequency, which is what Kieran was about to do, all right? How would we go about doing it? And then what would be the problem? All right? So should we draw this in now? So we need to, I'll do it. I don't want you to do it because I don't want you to have the wrong thing on your sheet. So talk me through what do we need to set up. So we've got the groups on the bottom, and if we make this this has to be frequency. And what would I label my diagram? What axis? What do I need to go from what to what? Greg?
You can go from like 10 to 30 or like 50. Yeah.
Does frequency have to start at 0?
No.
No? Okay.
Oh yeah, to 40.
So we need to get all the way up to 40. Now actually, because it's not too bad, I'm actually just going to do that because I've got enough space. So I am going to start at 0. Have I got space to do it as, so we've got an issue with the lines again, haven't we?
Yeah.
That one would be 10, is that right? So 5, 5, yeah, that's all right, isn't it? 10, and then 4, 5, so actually it's 20. Now it's clear actually. 30. Do I just need to go to 40?
Yeah.
Okay, so if we've got that, now you tell me the frequencies and I'll draw it then. So what's the first class interval? 60 to 65. I will say again, just to wait till Ethan's done a bit more, do not do this on your paper because we're doing the wrong thing. Say that again. All right. So what's the frequency of the 60 to 65? 15. So I'm going to go across to 15, and I'm going to put my line literally like that. Yeah. So that'd be the first bar. What's the next one?
60 to 70.
65 to 70, and it's at
20.
20.
25.
25. If I go up there, okay. All right, so far, we're all right. What's the next one?
70 to 80.
70 to 80, what's the frequency?
36.
36. Okay, so I need to do this 30. How far do I go?
A little more.
5. Like that?
Yeah.
Okay.
Wait, why is it
Because the classroom is 10 up to 100.
All right, so let's do that. Next one?
All right.
80 to 100, okay, which is
24.
24. Okay, so what's that? Okay, so here's the thing. So I've done that just as a normal frequency diagram. What are charts for? What are these charts used for? Why do I bother doing them now? Easily see the data. They're supposed to represent the data well. So what would I interpret from that diagram?
That there's, you can determine how large the class intervals are, and you can determine how the frequency within those class intervals, how many data points you can place within those class intervals.
Okay, so it says the table gives some information about the speeds of 100 cars. All right, which is the smallest group? Here?
Yes. Class interval.
Okay. Which ones? That's got the least in, yeah? Right? Now, if I'm looking at this graph, I'm supposed to be able to look at the chart and be able to make judgments quite quickly without having to think about it too much. All right? And I would be looking at that, and which group does my eye get drawn to a lot? The biggest ones, right? Normally with a frequency diagram, the highest bar is the largest, yeah? All right? But the trouble is, because the groups are bigger, like that last one is a really wide class interval. So of course it's going to have a high frequency. But does that mean in general more cars go at that speed, the high speeds? No. Okay? But if I draw my graph like this, it kind of looks like I've got this big overarching kind of, my eye gets drawn to those high speeds. All right? And that's because the groups are bigger and the frequency is therefore higher because the group's bigger. So it's not a very clear way of showing the data. All right? Because of course if I make the group bigger, I'm going to make the frequency higher. I want a better representation. If I've got a smaller group with, it might have less in it, but proportionally that might be more. You know what I mean? All right? So I need to show that on the graph, and this graph doesn't show it. All right? It shows the bigger group has the higher frequency. So what we have to do is we have to think about it a bit different. And what we don't do is we don't just consider frequency. We consider frequency.
Like divided by class?
Yeah, so we actually call it frequency density. All right? Where the area of the bar shows me the frequency. Is that clear? All right. So what I have to do, and this is why I didn't want you to draw it, I'm going to get rid of all of this. All right? Because it doesn't tell me exactly what I want. All right? And I'm going to go up here and I'm going to work out my frequency density. All right, so I want the area of the bar to represent the frequency. So we have to work it out. So what's the area of the first bar got to be?
5 times 50.
No. The area wants to be 15. The area of the bar is 15. That's what I want it to be. So I've got to figure out, so what's the class interval?
5.
5. So I need it to be 5 times, because that's the width, 3. 5 times 3 gives me the 15. So my frequency density is actually going to be 3. All right?
Why not 5?
This one then I've got 5 times what gives me 25? 5. So I've got to do 5 times 5 gives me the 25. This one is 10 times 3.6 gives me the 36. Yeah.
And then this one, it's 20 times
1.2.
So is it kind of frequency divided by class interval here?
Well, yes, it is, exactly. Yeah. That's how we've done it. So we've done frequency divided by the class interval, okay? Gives me frequency density, right? Now, this has changed my vertical axis. So what do I now need to have it at? So having it as up to 40 is not right. What was the maximum it needs to go to? 5. So I'm actually going to just do it as 1, 2, 3, 4, and 5. Now that's nice because exactly what I have. Right? And now I'm going to plot it like that instead. That makes sense? Yes. So I'm still going to use the same class interval. So this time, just to do the first one with you, what was my frequency density for the 60 to 65?
3.
3. So if I go across the 3, okay. So my first bar is like that. I'll let you carry on and do the rest of the bar. And we'll see what it looks like compared to what we did originally. So just to recap, I've added it to my notes a little bit tighter. So frequency density is frequency divided by the class interval, as you said. Okay. If we redo the graph now, compare that to what it looked like originally. What do you notice? Here? Yeah, which bar is your eye drawn to first? The tall one. Yeah, the 65 to 70. Right? And it's because proportionally the number of cars in that group is higher than in the bigger group at the end. All right? So that's what we're showing the frequency density. So as soon as you have a histogram where the class intervals are different sizes, you can't just do frequency, you have to do the frequency density, relative frequency. Okay? And it just makes it that little bit clearer to just glance at it and think, yeah, now I know what I'm talking about. All right? Okay, so can I just ask then? It says work out an estimate for the number of cars with a speed of more than 85 kilometers per hour. Guys, don't worry about colouring in now. I'm asking you a maths question. It's nice that we're crossing subjects, art, colouring in. Okay, but maths now. What do you think you would do to work out an estimate for the number of cars with a speed of more than 85 kilometers per hour?
So, an estimate.
Yep. Eva?
The frequency, so the class interval 80 to 100 is the frequency of this class interval is 24. Maybe we can start with dividing by finding frequency density, which is 1.2.
Yeah.
And then multiplying this, if this is only for one number, and it's 85, and 85 to 100 is 15, multiplying 1.2 by 15.
Say it again, sorry. So we're looking at these numbers. So you're looking at the 1.2 and you're multiplying by the 15 because that's...
No, by 15 because it's we charge it from over 85.
Yeah, 85 to 100.
is this one of this class interval is 15
How do you know it's 15?
because one of them has 85 is 15.
Oh, I see. Yeah. I get you. What were you going to say, Greg?
Yeah, I was just gonna multiply 24 by 0.75.
Why?
Because 24 is the frequency of the class interval of 80 to 100, and 85 to 100 is 75%. So multiply the 24 by 0.75.
Yeah. Does that give you the same answer?
I have 18, yeah.
So we've got two methods here. You did 75% of the 24, which is 18, and you did 1.2 times 15, and that gives you 18 as well. So you've got a couple of options there. You see, does everyone see the two different ways of doing that? Yeah? Do you understand where the 1.2 times 15 comes from? Go on then, Nick, explain.
This 15 is the proportion that you want to know, because that's past 85.
Yeah.
85 plus x equals 100, and x would be 15 in this case. And the frequency is 1.2 of those.
The frequency is not 1.2, the frequency... So I'm looking for the area of this,
Sorry.
so I know that's 15, and the height is 1.2. So that's that way. And we also get Greg's method because
75%.
75% of it.
Yeah, 75% of 80 to 100 is 15.
Yeah.
So
again,
we multiply 24, which is the frequency by.
so if the whole bar is 24, and we only want 3/4 of it, that's what we worked out. 15 of 20 is 3/4. Okay? Seems to work for us. So you've got just lots more of the same, to have a bit of practice or go through, you can pick your questions. I wouldn't spend a long time now colouring in your bars. Okay, go on and maybe find one that's just interpret the diagram rather than draw it from scratch. So yeah. Work out the proportion of apples in the sample with a weight between 140 and 200. So we're interpreting the diagram now rather than having to create it from scratch. If we want to know the proportion of 140 to 200, okay, we need to find the amounts. Yeah? How do we find the amounts? Well, the frequency is, how do I use the bar to find the frequency? But what do I use? No, I don't use them, because the vertical axis is actually frequency density, not frequency. What on this histogram shows me frequency? Not the width, not the height. Thank you, Greg. The area of the bar equals the frequency. Okay? So I've got to work out the area of the bar. So, for instance, this bar here has a width of 20, the class interval is 20, and the height of the bar is at 0.7. So my area is 20 times 0.7, which is... what's the answer? 20 times 0.7 is...
0.5. No, 0.6. 14. I mean, 6. I mean, 14. I had a
How do you get
calculation.
0 point
Look,
something?
trust me.
Times by 10 and then times by 2. That's the same as times by 20. Greg, what was your question?
Can you, what is the answer for this? 'Cause I tried to.
Yeah, I'm trying to work it out, and you keep stopping me asking questions.
Oh,
Like, what are the answers?
I think I got a.
So what's this one then? So the class interval is 40. 40 times 0. Not, is it 0.6? So easy to misread it. So what is it? It's not quite 0.1, is it?
It's 0.12.
0.12. Okay? So I've got 40 times 0.12 is?
Wait, don't you not need to know that? Data right there, though?
No, you do.
I do because I have to work out proportion. So what is it?
Oh, yeah.
4.8. So I have a frequency of 4.8. Sure?
Yeah, it's 4.8.
4.8. Okay. This one then, I've got 20 times 20 times 0.36 is?
I think that's 0.38.
I think it's 0.26. Yeah, 0.26.
Wait, 0.3
Because each little square is worth
It's 0.36.
0.02. You've got to be very careful. So we've got that. The next one again is 20, so it's 20 times, and this would be 0.56, which is
No, 2.2, 2.32, 2.32. Let's go.
2.32.
I think.
Huh? It is 11.2.
It's 11.2.
What did I say? 2.32. I meant I did.
And this one, finally, we've got 40, so 40 times, what is it? 0.18. Okay. Which is 3.6. Okay, so work out the proportion of apples in the sample with a weight between 100.
Wait, what? That doesn't make sense.
Yeah, it does make sense.
No, I got.
What did you get? 7.2.
False.
It is
Yeah,
7.2.
so did I, sorry.
Okay.
Wait a second.
How could that be lower than?
So work out the proportion of apples, guys, in the sample with a weight between 140 and 200. So 140 to 200 is how many?
16 plus 11 plus 16.
So it's 7.2 plus 14 plus 11.2 is
32.4.
It is 32.4? Yeah, it is.
okay. And then it says what proportion of apples. So I need to know the total. So I've got to do it's 32.4 out of 4.8 plus 7.2 plus 14 plus 11.2
Is it perhaps
plus 7
44.4?
is what?
44.4.
44.4 is it? So that's nice. So the proportion
Wait,
is
44.4.
sorry, yeah. So 32.4 divided by 44.4 gives you
72.79. I mean 72.97.
percent. Okay. What's up?
So the method I was telling you I got for the answer.
Yeah.
So I got that answer, and what I did was for the proportion of the apples between 140 and 200.
Yeah.
I calculated the frequency. I found the frequency density of all of them, but then I just averaged it, and then did 60 times 0.54, and then did the same thing for the total.
Yeah.
So instead of, I didn't have to worry about the area because for like the two on the left and the right, I just did it twice because the frequency, the class interval for the ones on the left and the right is just 40 instead of 20.
Yeah.
So instead of doing 40 times 0.12,
Yeah.
anyways, I added it twice. So then I calculated the total, and then yeah, I got 44.4, and then I just did the rest the same. So finding the average works for me.
Finding the average one.
Yeah.
So you got the idea? Everyone, is that all right? So it's that again. Can I just ask you though, how come the frequencies are decimals?
Sorry, what do you mean?
Weight, oh, because it's weight.
So this is something that I would say more NYP than IGCSE, for instance. If this was a criterion D assessment, you've got to talk about what?
A real world example, like about the apples and stuff.
Okay, so this 4.8 tells me what? That there are 4.8 apples that weigh between 100 and 140. Comments?
You can't have 4.8.
No.
Can't have 4.8. So we would talk about its appropriateness based on the situation we're in. But of course you would then be going, well, actually, you can't have 4.8 apples, but why have I got 4.8 apples?
Rounded.
Because we've been rounding, haven't we? When this data was collected and put into the graph and that kind of thing, rounding has affected these things. Yeah? We can't have 4.8 apples. Right? How did we do it then? How do you think they collected this data so that we have ended up with 4.8 apples?
You're taking an average. Well,
Yeah.
Well, Nick had his hand up,
I'm
and
sorry.
he was about to say that, wasn't he? So, yeah. If you think about apples and how many apples that we're kind of potentially dealing with, they've probably taken samples and therefore worked out averages and things. But there are reasons, and then that for you being an NYP is the kind of things you could discuss with questions like this, where you can see being an IGC question, just to use it, is it doesn't ask you those sort of things. That's where you would have to have a better understanding of the whole situation. Greg?
I can't think of any situation where it would be advantageous to have a class interval that isn't like advantageous to not have all the class intervals be the same. It just seems like it's hard.
That's a very good endpoint. We will talk about that. It's actually in your textbook of why you would pick out, because we've talked about it before, about how much detail do you actually want. We don't need to stand up and start packing up my 3-minute bell. Here. I
Oh,
know.
it's 3 minutes?
3 minutes now.
That's all it's
I think they changed it. It's my time, my warning to be starting to wrap things up so you're not late to the next lesson, but it's not time for you to get up. What we talk about next, just to let you know, is we start going on in your textbook to think distributions and what happens if you pick different. So you can see that if I have very small ungrouped data, look at all the different bars.
Yeah.
There's lots of them. There's no real pattern to it. However, if I make the groups quite large, look what happens. I get some shape to the distribution, right? But I lose some detail. So this looks like I have a single mode, but I have a nice frequency. That looks nice. I could deal with it like that. But if I cut them down a little bit, but don't make them as small as before, I change the shape even more. I have even more detail, but not too much detail.
I like that one.
Okay? So we have to, at some point, this will be the next thing to talk about, is when you have to decide your own class intervals, right, you might have to do a bit of playing around to decide which one gives you the right amount of information. Does that make sense?
Yeah.
Okay. Cool. Talk about that next time.